Morning, guys. So in 9.7 we're going to work with those special products again. Okay, remember the perfect squares we talked about when we were doing multiplying polynomials and the difference of two squares. Okay, so now we're going to do those in reverse order, right? We already did them. We had to multiply it out, right? Remember with this perfect square, or the difference of two squares. When we FOIL this out, the middle terms canceled out, and we're left with a squared minus b squared. Okay, so now if we have something that looks like a squared minus b squared, basically a perfect square in both terms, and a minus sign on the in-between, you can rewrite it as a plus b, a minus b, right? And then the perfect squares, remember this, when we actually squared these out, these terms out, it came out to a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, okay? So the only difference between the perfect squares are the plus signs go with the 2ab if it's on the inside, and the minus sign goes with the 2ab if you have a minus sign in there. So let's show you how to factor these. Okay, so this first one looks a lot like a squared plus b squared, right? Because y squared is a perfect square, and 9 is a perfect square. Okay, so we take the square root of both and write it as a plus b, a minus b. Okay, so the square root of y squared is y, and the square root of 9 is 3. So you write it as y plus 3, y minus 3. Okay, now the second one, right, this is also a perfect square, and this is a perfect square, so it's going to be the same type of thing. I've got to figure out what the square root of both of those is. Well, the square root of 64c squared is going to be 8, because 8's the square root of 64c. Okay, because 8c times 8c is going to give us 64c squared. And the square root of 16 is 4, so 8c plus 4, 8c minus 4. Okay, that's all you got to do with these. 3 and 4 are very similar. They're also a difference of two squares, right? Notice that these have to be minus signs. If either of these is a plus sign, you can't factor. Okay, but since it is a minus sign, we're just going to take the square root of both. The square root of x squared is x. The square root of 81y squared is going to be 9y. So we're going to have 8 plus, or x plus 9y, x minus 9y. All right, and the last one down here. All right, this one's a little bit tricky because we don't have perfect squares. Okay, 12's not a perfect square, and 48's not a perfect square. But we could do some factoring to get us some perfect squares. So what could we take out of both 12 and 48 to get to a perfect square? Well, if you take 3 out of 12 and 48, okay, so if you take a 3 out, then you'd be left with 4. And if you take a 3 out of 48, you're left with 16 m squared. Okay? Now when you look at this, you see that 4 is a perfect square and 16 is a perfect square. Now we can do the difference of two squares because we have the minus sign in there. So we can continue to factor this. It's going to be 3. The square root of 4 is 2. Square root of 16m squared is 4m. So 2 plus 4m, 2 minus 4m. Looks just like that. All right, let's go to the perfect squares. So for these perfect squares, remember that basically all of these are going to be in the form either a plus or minus b with the whole thing in parentheses squared. All we really need to look at is this sign. This sign is going to be the key. Okay, we're going to take the square root of this and the square root of this and then take this sign. Okay, so for this first one, it's going to be a. A is the square root of a squared. The square root of 9 is 3. The whole thing's going to be squared, and we're going to take that sign, so it's going to be plus. Okay, and then you could obviously check your work here by actually squaring this out, and you're going to get a squared plus 3a plus 3a plus 9. And 3a plus 3a is 6, so that's how you got that. Okay, number 6. Okay, we're going to take the square root of this one and the square root of this one and take the sign. So the square root of n squared, or 4n squared, is 2n. The square root of 25 is 5. And now we can double check to see if this is actually correct. I'll actually do this one. Okay, this is the same as 2n plus 5 times 2n plus 5. Right, this is just my checking. Right, all you need to do is this. This is just checking my work. Okay, so when you FOIL this, right, you're going to get 4n squared plus 10n plus 10n plus 25, and 10n plus 10n is 20n, so it is actually correct. Now number 7 here, once again, we're taking the square root and the square root and seeing if it, and taking the middle sign. So we've got a 3c minus d squared. Okay, see, I took this negative, and that's what goes in the middle. Okay, once again, to check my work, this is 3c minus d times 3c minus d. Alright, so let's double check this. Do all my foiling, and I'm going to get 9c squared minus 3cd minus 3cd plus d squared, because we got a negative d times a negative d gives us a positive d squared. So these two combine to make a minus 6cd, and we are good. Now the last problem here, right, this one's a little bit of a problem. We need to do some factoring first. Okay, first of all, we don't like the negative sign, so we need to pull the negative out. But also, this isn't a perfect square, and that's not a perfect square. So because of that, we're going to try to factor out a 2 out of all of these and see if we're left with a bunch of perfect squares. So we'll take a negative 2 out, and we'll be left with, when you take a negative 2 out of negative 2x squared, you're left with just x squared. When you take negative 2 out of negative 16, you're going to be left with plus x, or sorry, 8x plus 8x. And we take a negative 2 out of negative 32, you're left with plus 16. Now we look at these and we see perfect square, take this sign. Okay, so this is equal to negative 2 times x plus 4 quantity squared, and that is factored. Now let's go ahead and check this one just to make sure it is correct. So we've got negative 2 times x plus 4 times x plus 4. Alright, I'm going to do my x plus 4s first. Okay, do my foiling. I'm going to leave the negative 2 out front. So we got an x squared plus 4x plus 4x plus 16. Okay, these two combine to create an 8x. So negative 2 times x squared plus 8x plus 16. And now I can distribute my negative 2 in there to see what I get. See if that's the same thing I had in my original equation. Negative 2x squared minus 16x minus 32. That is the same as what I had here in the original, so it does check out. That's it, guys.